Hey, in this video we're going to be dealing with division of fractions. We're going to divide our fractions. There's just one step that changes, or that is the difference between division and multiplication. We're going to take a division problem, we're going to make it a multiplication problem to solve. It's the only way you can solve, or only way you can find the quotient of a division problem. So one of the method that I use is called KFC, just like Kentucky Fried Chicken. That's what I think of when I say KFC. So the K stands for keep. So I'm going to keep the first fraction just like it is. The F is flip. So I'm going to flip the second fraction, which means I'm taking the reciprocal. I'm changing top over bottom. And then the C is for change. I'm going to change the division to multiplication. Okay. So looking at the first problem in the first row, I keep the first fraction, I flip the second fraction, and I change the sign in the middle. Change my colors up a little bit here. So I'm going to keep the first fraction as 50 over 19. I'm going to change the sign in the middle to multiplication, and I'm going to flip my second fraction, making it 19 over 49. Get a different color here that can be seen. And then I'm going to look, is there anything here that will cancel? Yeah, I've got a 19 on bottom and a 19 on top. So I know they both become ones. Does anything go into 50 or 49? Because we treat it, once we flip it and make it a multiplication problem, we treat it just like we do any multiplication of fractions. So there's nothing goes into 50, nothing that goes into 49. So I multiply 50 times 1, and I get 50. I multiply 1 times 49, and I get 49. So I have 50 over 49. And again, we're not going to write our improper fraction as a mixed number unless our directions specifically tell us to. So let's look at the second fraction. So again, I'm going to keep, flip, and change because it's a division. So I'm going to keep the first fraction as 7 over 30. I'm going to change my division to multiplication, and I'm going to flip my second fraction, making it 48 over 4. Now, we can do this two different ways. I don't know what color I want to use. We can cancel. Like I know 4 goes into 4 one time. 4 goes into 48 12 times. It's kind of hard to see. Don't want to use that one again. That leaves me with 7 over 30 times 12 over 1. And then I also know that, oh, hey, 3 goes into 30 and 3 goes into 12, and I cancel it one more time. Or I can look at, oh, it just hit me. 6 goes into 30 and 6 goes into 12. So I can divide both of these by 6. 6 goes into 30 5 times. 6 goes into 12 2 times. And now I have 7 times 2, which is 14 over 5. You can always cancel. I could have multiplied straight across and reduced my final answer. Or I could have done the prime factorization, like I did in a previous video. All right, let's look at the next one. And again, to get it into multiplication, I'm going to keep, flip, change. So I'm going to keep my first fraction as 18 over 36. I'm going to change my division to multiplication. And I'm going to flip my second fraction, making it 26 over 34. Okay, I'm going to work this one just a little bit differently in the fact that I'm going to work it as, make it all prime numbers. So if I break 18 down to primes, 18 is 2 and 9, 9 becomes 3 and 3, so I have 2 times 3 times 3. 26 is 2 and 13, those are both prime. And then on the bottom, 36 is 4 and 9, which would be 2 and 2, 3 and 3. So 2 times 2 times 3 times 3. And 34 is 2 and 17. I can look at what's going to cancel. Okay, so remember, for every number I have on top, I can cancel that number on bottom. So 2 on top cancels a 2 on bottom. A 3 on top will cancel a 3 on bottom. This 3 will cancel this 3. This 2 will cancel this 2. And then nothing else cancels. So that leaves me with a 13 on top, a 2, and a 17 on the bottom. So I have 13 over 2 times 17, which gives me 13 over 34. It's a little bit longer of a process sometimes, but you're definitely going to get the right answer. Okay, so let's look at the next one. This time we're taking a fraction, dividing it by a whole number, but we're still going to use the same process. So I'm going to put my 6 over 1, so I've got my whole number written as a fraction. I'm still going to keep, flip, change. So I keep the first fraction like it is, the 49 over 12. I flip the second fraction, making it 1 over 6, and I change the division to multiplication. And then I'm going to either cancel or multiply or something here and see what goes into what. I don't have anything. If I take it to prime numbers, 49 is 7 times 7, and I have that 1. 12 is 2 times 2 times 3. 6 is 2 times 3. Let me do this 12 so you know what I'm talking about. 4 times 3. 4 is 2 times 2. That's where I get the 2 times 2 times 3. So I have nothing on top that matches on bottom. So then I'm doing 49 times 1 and 6 times 12, which is 72. 49 over 72 is my answer. So, okay, let's look at the next one. The 9 over 13 divided by 7 over 12, I'm going to keep, flip, change. So I'm not going to change colors this time. Other than I'm going to change out of my red. So I have 9 over 13, flip my 7 over 12, and I get 12 over 7. Change division to multiplication. Then I look at what cancels. 9 times, nothing cancels, so I multiply straight across. 9 times 12 is 108. 13 times 7, 7 times 3 is 21. 7, that'd be 91. And then that is my final answer. So then let's look at the last one. 2/5 divided by 0. I don't even have to work this one. Anything divided by 0 is undefined. If it's undefined, then in Hawks you're putting NS for non-solvable. But anytime you're trying to take something and to put it into no sets or no groups, then you can't do it because something can't be broken down into nothing. I have something to begin with, I'm going to have something in the end. So to divide it into nothing won't happen. That's the reason it's undefined. If you were to put 2/5 divided by 0 in your calculator, you would get an error message. And that is the end of this video.